Okay, so you've heard a bit about the centre, and I didn't really tell you about what NDE is. I'll just very quickly, of course, I'm sure you all know, but very quickly, it's about the detection and characterisation of defects in engineering structures. And it's not just about acoustics, but acoustics is a strong part of it. Obviously, that's the link with this group here, but it includes other things as well, like electromagnetics, for example. But in terms of the acoustics links, that's trying to do things like characterise materials, permanently installed systems for SHM, arrays, for imaging, laser-based ultrasound guided waves, nonlinear methods, you know, the list goes on. Clearly it draws from a wide range of existing techniques, try to develop new ones, and apply them to this, this industrial problem. So I want to, I suppose, get across here that it's a reasonably well-known problem, that the idea that structures age and fail and they need to be tested, but it's maybe not quite as well known as the noise pollution problem we've just been hearing about. But there's a long tradition of the UK leading the way in NDE. The top row are commercial things, Ductosense, array imaging, and permanently installed sensors by Permasense, which are UK-driven research that is now UK commercial success stories. And the bottom are perhaps some things that are going to emerge over the coming years. So where are the gaps? Why do we need to link to this network if we're already doing so well? Well, I think the reason is that NDE, there is two sides to NDE. One is people who work in NDE are always listening and looking for things that they can use to do better NDE. In parallel with this, though, we have a whole lot of problems that are put on our plates by industrialists as structures get more complicated, as new materials are introduced. Heaven forbid we have to do NDT on metamaterials, but anyway, that's something we haven't yet had to deal with. But as materials evolve, so you need to come up with NDE solutions to those problems. So that's in that mode we are looking for solutions. So there's a lot of opportunities because it's a thriving field and there are real challenges. We're trying to make these measurements, but make them in very, very precisely, but in incredibly difficult circumstances. You know, dangling off a rope, trying to inspect the leg of an oil rig, for example, or deep below the ocean. So trying to do hard measurements in difficult places. So there's a lot of economic drivers to do this faster and better, and to permanently install systems to make this whole process cheaper. So there's quite clear economic drivers there. So it's those drivers that mean that we can connect to industry. Connecting with academia, though, is because the subject is quite applied, but we are requiring new techniques, which quite often come from other disciplines, for example physics, but I think they also come from other acoustics disciplines, and I think that's what the link I'm hoping this SIG will make with the other communities here. I think there's a lot of ideas, some of which are being pursued for all sorts of different purposes, but not NDT, and I'm hoping, or NDE, and I'm hoping we can pick up on those and find uses for those in this field. But I think it's a two-way process. I think it needs to be a collaboration between the people that have a clear understanding of those applications, and those are academics and industrialists, and the people that come up with those solutions. So you can see this collaboration is really critical, and I think that's what the network's all about.